So let's check this exam problem. We have a reinforced concrete beam that it is subject to a factored moment of 648 feet kips. This is factored moment, so this is the M ultimate, and the concrete FC prime equals 4000 psi, and the steel F field equals 60,000 psi. The beam is reinforced with number 8 bars in 2 rows, positioned as shown in this figure, and this is the figure that we have here. It may be assumed without verification that phi equals 0.9. This means it is a tension controlled section, and we don't have to go through the steps to verify the value of the phi. We can take it directly as 0.9. The minimum adequate overall width, B, to the nearest whole inch for the beam is most nearly. So we want to calculate B. We want to know what is the minimum width required for this beam to be able to resist this factored moment. In order to do that, let's start by the values that we already have here. And the first one, which is the Mn, which is the nominal moment of this beam, and it equals the M ultimate over phi. We have the value of the M ultimate and we have the phi. But what does Mn equals? We know this equation also, which equals area steel multiplied by F yield multiplied by D minus A over 2. And we know that A equals area steel multiplied by F yield over 0.85 FC prime multiplied by B. All of these equations which we have in the reference book. So this means that Mn, which is the M ultimate over phi, equals area steel multiplied by F yield multiplied by D minus half. This half because A here is divided over 2. So minus half multiplied by area steel F yield over 0.85 FC prime B. Let's calculate the area steel. It is very simple. Here we have 8 bars of number 8. We can take the area of the number 8 bar from the table which we have in the reference book, which equals 0.79 inch square. So area steel equals 8 multiplied by 0.79 equals 6.32 inch square. Now we have all the values here of this equation except for D. Let's calculate D. D equals 30, which is the overall depth of the beam, minus 3.5, which is this 2.5, and 1, which is here in the middle between these 2 rows. If it was only 1 row, it was going to be only 2.5, but these are 2 rows, so it is going to be the midline here between these 2 rows. So it is going to be 30 minus 3.5 equals 26.5 inch. Now we have all the values, and let's calculate this, or let's substitute in all of these values here. M ultimate equals 648 multiplied by 12 because this is feet and we will use inch in our equation, over 0.9, which is phi, equals 6.32, which is the area steel, multiplied by 60, which is the F yield, multiplied by 26.5, which is D, minus half, multiplied by 6.32, which is area steel, multiplied by 60, which is F yield, over 0.85 multiplied by 4, which is FC prime, multiplied by B. You can see that we took here the FC prime as 4, not 4000, because we took the F yield as 60. So it is per KSI, not PSI. So we have now this full equation. All values are known except for B. We can simply solve this equation to obtain B, which is going to be 14.92 inch. So this means that the minimum required width for this beam to the nearest whole inch equals 15. And this is our solution here. So thank you. See you in our next video.